In this example, a hockey puck of mass 0.3 kilograms is on a frictionless horizontal surface. Two hockey sticks exert forces on the puck at the same time. The forces are not along the same line, so we cannot simply add their magnitudes. We must break each force into x and y components, find the net force components, and then divide by the mass to find acceleration. The next slide shows the component calculation. Let's first talk about how to calculate the components of these forces. For F1, the x component, let's say F sub x, and equals to F1 cosine, and then when you put down the angle, you have to put the angle from the positive x-axis, and here the angle from the positive x-axis is 20 degrees, and it is measured in the clockwise direction. So if you have an angle measured in clockwise direction, that will be a negative angle. So this is negative 20 degrees. So F1 is equals to 5 newtons. So 5 newtons times cosine negative 20 degrees, and that's going to give us the x component of this F1, and that is equals to 4.7 newtons. And then we can look at the y component of F1. So F1y is given by F1 sine negative 20 degrees, and that is equals to 5 newtons sine negative 20, and that is equals to negative 1.7 newton. Similarly, we can find F2x, which is F2 cosine 60. Now here, this 60 degrees is measured in the counterclockwise direction, so it is just a positive angle. So this gives you 8 newtons times cosine 60, which is equals to 4 newtons. And then F2y is equals to F2 sine 60, and that is 8 newtons sine 60 equals to 6.9 newtons. Now we know the x component and y component of both forces, so we can find the net force. F net x is equals to F1x plus F2x, which is 4.7 newtons plus 4 newtons. It gives us 8.7 newtons. And then F net y is equals to F1y plus F2y, which is equals to negative 1.7 newtons plus 6.9 newtons, and that is equals to 5.2 newtons. We found that the net force in x direction is 8.7 newtons, and the net force in y direction is 5.2 newtons. Now we have to apply Newton's second law to these values. So Newton's second law is F net equals mass times acceleration, and we can write this in component form. So net x is equals to mass times acceleration in x direction, and F net y is equals mass times acceleration in y direction. So let's rearrange these equations to find acceleration. So acceleration in x direction is equals to F net in x direction divided by the mass. So in our problem, the net force in x direction is 8.7 newtons divided by the mass, which is 0.3 kilograms, gives us 29 meters per second square. So that is the x component of the acceleration. And to find the y component, use the same thing, F net y divided by the mass. So the y net force we found as 5.2 newtons divided by the mass 0.3 kilograms, and that is going to give us 17 meters per second square. Now you can indicate this as a vector. Acceleration vector is equals to 29 x hat plus 17 y hat meters per second square. Or you can write this as 29 I hat plus 17 j hat meters per second square, depending on the notation you are using. If you have to find the magnitude and the direction of this vector, we can use the Pythagorean theorem. So the magnitude of vector A is given by the square root of the x component of vector square plus the y component of vector square. So this is equals to 29 square plus 17 square root, which is equals to 34 meters per second square. And to find the angle, we can use theta equals tan inverse the y component of the acceleration divided by the x component of the acceleration, which is equals to tan inverse 17 divided by 29, which is equals to 31 degrees. So the acceleration is 34 meters per second squared at an angle of 31 degrees above the positive x-axis.